Alrighty, finishing number 34. So if we solve this using trig, we have 18, and we want to find the leg. So we have our opposite, and we have hypotenuse. So that's sine of 45 is equal to x over 18. And we cross multiply. 1 times x is x. 18 times the sine of 45. Type it in. And we have 12.7. So either of those would be appropriate answers. Okay, number 35. Looking at this, if we wanted to do this using our trig functions, we can, and I will do that over there, but we're going to find both x and y. If we memorize the pattern for the 30, 60, 90, we had our value, our value times the square root of 3, 30 and 60, and then 2x. So if we follow the pattern, we have our x is 13, meaning this would be 13 square root 3, and then 2 times 13 would be 26. Again, we could use trig to solve this if we wanted, so I'll redraw this and use trig. 30, 13, x, and y. Alrighty, so I'm going to start with x. I would use the tangent 30 is 13 over x. I'm going to cross multiply, so x times the tangent of 30 equals 1 times 13, or 13. Since x is not all by its lonesome, we need to divide by the tangent of 30. Divide by the tangent of 30. 13 divided by tangent of 30 is 22.5. So again, if we went in our calculator and did 13 times the square root of 3, we would also have 22.5. So if this is 22.5 and this is 13, I have two options to solve this. I can use Pythagorean theorem, since I have two measures and just need the third, or I could use trig again. Since I like trig, I'm just going to say the sine of 30 is 13 over y. Cross multiply. Y times the sine of 30. Y times the sine of b. Oh boy, I'm losing it. Over 1. 1 times 13 is 13. Divide by the sine of 30. Divide by the sine of 30. And I get 26. Alrighty. For 36 and 37, it says find the missing value. So this program that creates these questions don't look exactly the same as we saw them in class, but they're really asking for the angle measure. What angle has a tangent of 52? What angle has the sine of 10 over 16? So I know I am just doing the inverse function in my calculator. So second tangent, 52, and it gives me 89 degrees. Oh, that says to the nearest hundredth, so 88.90 degrees. Alrighty, on the next one, second sine, 10 over 16. And we get 38.68 degrees, or if we're to go to the nearest degree, 9, any of those would be appropriate. Number 38, write the tangent ratios for P and Q. I'm going to go ahead and do all of them just so it's a nice review. So we're going to look from two different angles, angle P and angle Q. Just so this is a review for anybody that may have been absent. Okay, so we are looking for SOHCAHTOA. So that reminds us that sine is opposite over hypotenuse, that cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we're looking from angle P, 9 is my opposite, 15 is my hypotenuse, and 12 is my adjacent. So sine is opposite over hypotenuse, so opposite to P is 9, hypotenuse is 15. Cosine is adjacent over hypotenuse, so 12 over 15. And tangent is opposite over adjacent, 9 over 12. Now when I look from Q, my hypotenuse is still going to be 15, but my opposite and adjacent change, because now my opposite, what's across Q, is 12, and adjacent will be 9. So sine of Q would be 12 over 15, opposite over hypotenuse. Cosine is adjacent over hypotenuse, so 9 over 15. And then tangent of Q is 12 over 9. So the real question was just the tangent of P and Q. So it would be 9 over 12 for P and 12 over 9 for Q. But again, there's some extra. Alrighty. Write the ratios for sine A and cosine A. Sine A, cosine A. Alright, so for looking from angle A, and again, sometimes we see the little theta right here. This would be my opposite, across from, adjacent, next to my 90 degree, and hypotenuse, the opposite of 90, my diagonal value, my longest. Okay, so sine is opposite over hypotenuse, so 48 over 50, and cosine is adjacent over hypotenuse, so 14 over 50. Number 40, use a trig ratio to find the value of x. So when I'm looking from 60 degrees, I just ask myself, what is the opposite, where's the adjacent, where's the hypotenuse? So 7 is my opposite, and 60 is adjacent. So which trig function uses opposite and adjacent? So if we remember from SOHCAHTOA, that tangent uses opposite and adjacent. So the tangent of 60 degrees, so our angle always goes here, is equal to opposite over adjacent. So when we put our value over 1, now we can cross multiply. So we have x times the tangent of 60 is equal to 1 times 7, or 7. Since x is not by itself, we need to do the inverse of multiplication, which is division. I get x is equal to 7 divided by the tangent of 60, and we get 4.0. So if you're getting a weird number in your calculator, again, remember that, check your mode and make sure you're in degree mode. So mode is the second button along the top.